Yeah.
Alright, so we ended talking about our
I think you're pretty. Mr. Howard, you should have
our two types of waves, right, Ashley?
Yeah.
Our first was our longitudinal.
Yeah.
And we discussed the fact that both our velocity and our wave are moving parallel to each other. Okay? Whereas our transverse, our velocity is moving from left to right, but which way is our vibration moving?
Up and down.
Up and down. That's right. So if we look at an individual, just like remember on this one, each of these individual particles are just bouncing back and forth, transferring energy. Whereas this guy down here, we have each individual particle is bouncing up and down. Okay, so if you think of a wave in water, the energy is traveling through the water, but the water molecules themselves are just rising and falling. All right. Now that's not taking into account like currents and low tide, high tide due to the moon and all of that. I'm just talking about if you have a pool of water and you throw a rock into it, or something into it, it's going to, those ripples, basically that energy that disperses, the molecules themselves go up and down. You good?
Yep.
Appreciate it. And that's where we ended with this. Questions on this? This is what we're going to be focusing on, the transverse, for the most part. All right, so this is where we need a graph paper. Get out a piece of graph paper. Where have you seen this graph before? Velocity. That's right, our velocity graph.
How big does it have to be?
This should like 6 squares tall.
Yep.
They've all been stolen or destroyed or thrown away or broken. Yeah, careful. No, this time for real.
Okay.
I agree.
The high scholar you said.
It's still recording, you guys.
We still record hi, man.
Okay, but hi.
I don't like you guys.
Are you sure you didn't say Kylie?
No, this guy.
You said Kylie.
Alright, so
I like Kylie.
after you have your
Kylie.
ladies. Unnecessary. Again, unnecessary. So, what is our x-axis?
The second.
Which is a unit of time. Yes, our x-axis is time, and our y-axis is displacement. All right, so we're going to draw a wave on here. It looks like that. You need to draw a similar wave. Notice that the most important thing is where your wave crosses the x-axis.
You can explain?
Yes. Apparently on Monday I need to do a graph paper check. Well, you're not the only one. There's half the class. Yes, it's where the wave crosses. So in this case, the wave first crosses the x-axis halfway between 0 and 1 second. So like half a second, right? and then it crosses again in a second, and then it crosses again at a second and a half, and then it presumably crosses again at 2 seconds.
Okay.
All right, so we're going to label our parts of our wave. The first thing is going to be this length here. What would that be called?
Wave.
The wavelength, yeah. Anyone know what the symbol for wavelength is? Symbol.
That, like, weird looking kind of A thing.
Weird looking kind of A thing.
The upside down line.
Upside down Y. Anyone know what that's called?
It's not that big. Upside down.
It was right there. Well, here's a way that you can remember it.
Yeah.
No.
Okay.
So this looks kind of like a.
It looks like a turtle. Without its it's a kangaroo. Is that a lamb?
It's a sheep.
It's a lamb.
lamb?
Duh.
I thought it was a dinosaur.
Dinosaurs don't say bah.
Well, you didn't put that there. She thought that was before.
Of course, it's a length, so we measure it in meters. Okay? Now, it should be pointed out that a wavelength is an up hump and a down hump. Okay? An up, one down.
Is that one?
That is one wave. Yes, that's one wave.
One lamb. I can't.
All right, so what is the up called? Yeah, UH.
Of course.
The up.
The wave.
The top of water waves are called this. It's a toothpaste,
Colgate.
grocery store.
Press.
Yeah, it's a Colgate grocery store. The tsunami caused a enormous Colgate.
Yeah, it's just like
What is the bottom?
Target.
You have to have a pen.
Valley.
Who said Target?
Pigs eat out of this.
Trough.
A trough. It's amazing.
I know that.
Wait, what is? Wait, yeah, amazing.
Know your farm animals and what they eat out of.
Tyler, you should have an imaginary
Are you there right now?
I wish. I need to draw this picture.
My arrow's on your plan.
This height here, which is from your x-axis to the top of your crest, is the same as from your x-axis to the bottom of the trough. Okay? So these are mirrors, images, just offset by one. What is this called? Anyone know the height? What's this called?
Width.
What that specific height's called?
Another hint.
Another hint. All right, word games. If you are on the top of Mount Everest, you are at a high.
Elevation.
Okay.
Elevation?
Okay. The object you are going to plug in a electric guitar to.
Amp.
Amplitude.
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 I was close.
Mr. House.
Yes.
The height thing, it goes in each wave thingy.
Yes. Yes, that's another good point, is that this height, this amplitude, is going to be the same for every crest and for every trough. It's going to equal the same number.
Really?
Really.
Wait, what?
The amplitude is going to be the same throughout the wave.
Okay.
The wave gets like narrower.
It's still going to be the same height, it's just narrow.
We won't deal with any changes in wave. If I give you the wave like this, it'll be this forever, as far as I'm concerned. Okay, we're not worried about modulation and all of that.
I like that word.
Um,
I know it like you.
the companion to wavelength is frequency. Okay, wavelength is how long a wave is. Frequency is. Wavelength is how long the wave is in meters. Frequency is how many you have per second. That's right. Yeah, it says waves per second. That wasn't a trick question. Frequency symbol is a lowercase f.
It was like Facebook. The F way does.
And the unit is hertz.
Is hertz a capital H or
It is a capital because it's a guy's name.
Is her like the batteries?
It was a rental car place.
Yeah. My mom went there. What?
All right, so with that being said, let's look at this wave. How many waves do we have per second? Reminding yourself that one wave is one crest and one trough.
Two.
One.
Here's another way to figure it out, okay? And I want you to write this down. So in order to find frequency, you add your crests plus your troughs divided by 2 in a 1 second section. Okay? How many crests, how many troughs for 1 second divided by 2? Add your crests and your troughs in a 1 second section divided by 2.
So in this case, if we go plus 1 divided by 2.
Yes.
That's stupid.
Divided by what?
2
you said 1 second what?
in a 1 second section. So we have how many crests in the 1 second section? 1 crest. How many troughs in 1 second section? 1 trough. That equals 2 divided by 2 equals
0.
One.
unit.
I said 0.
Unit.
1 hertz.
Thank you.
Wouldn't we be hurt?
No.
Let's draw a second wave underneath this one. Keep your y-axis, just continue that down, and keep your 1 second mark at the same point. Last. All right, so let's draw our wavelength. How long is our wavelength going to be? Is it going to be longer or shorter than our first one?
The same. Wait.
Shorter. It's shorter.
Remember, wavelength is one crest, one trough, right?
Yeah.
So it's only going to be that long, because that's one crest, one trough, one wavelength. Remember, this is also like a backward, sideways S, right?
Right.
That's complicated though.
Don't say that to me.
It looks like a Z. What are we talking about?
What are we talking about? It looked like a Z, yes.
The serpentine.
They're like double.
The serpentine. The what? The what? Serpentine. What's that word again?
What is our fricassee? What, you don't like fricassee? Two? How do you know?
Because there's line 2, line 2.
You got the unit.
Oh no, you were doing fine explaining.
4 and 2, and then 5 by 2.
So you have 2 up here, 2 down here, that equals 4.
Yeah.
4 divided by 2 equals
2.
2 hertz.
2 hertz.
Questions on that?
I'm trying to draw the box first, and then it doesn't fit in.
It's terrible. Why don't you draw the box second? And then lastly,
No, you must.
so what's happening to our wavelength on this third one? It's getting even shorter. And then adding up our crests and troughs divided by 2.
3 hertz.
What is our frequency?
Can I draw?
3 hertz.
3 hertz. I agree with that. All right, we're comfortable with that.
C.
Good. Now, looking at the relationship between frequency and wavelength, what is happening to our wavelength
The smaller
at each progressive one?
wavelength, the bigger the hertz.
Okay, so the smaller the wavelength, what happens?
The bigger the
The bigger the hertz, the bigger the frequency. So, what is our relationship between frequency and wavelength?
And is it inversely?
Inversely proportional. Write that down. Frequency and wavelength are inversely proportional.
High school inversely.
Inversely. Yeah, the N.
I-N.
I-N.
I know that, but I got
I-N.
later.
N-I.
Yeah.
Yeah.
That's how you did it.
I don't get it.
She said that. No.
Say the word.
Inversely.
What's proportional?
What? Nothing proportional. Inversely proportional.
The length and frequency? No, wavelength.
Wavelength and frequency, yeah. Oh, of course it is. All right. In addition to our wavelength and frequency,
Right?
we have a third variable.
This is back to our notes.
Yes. That's right, Cena.
I get it.
Frequency, yes. That's what I said.
No.
And that third variable is the period of the wave. Now, that is determined. Well, first of all, let's back up. What was frequency again?
It was waves per second.
Waves per second. Okay? The waves period is how many seconds per wave. Okay, so frequency, as I like to say, frequency is waves per second. The period is seconds per wave. What is your unit for this?
Seconds.
Seconds. Right? Okay, and our frequency was what?
Waves per second.
Waves per second, and that is, you're right, in hertz. Or in s to the negative 1.
Why is it negative?
That's exactly what we're going to talk about. What does the s to negative 1 mean? What does this negative 1 mean? Math. Think math.
The little dot goes over.
The decimal.
That was dumb.
Okay. What does it mean in terms of fractions?
Fractions. Oh.
Okay, well, let's back up then. What is that?
What is that? Is that a V?
Is that a V or is it a 1 to the negative 1?
Oh.
Oh,
What does that equal in a fraction?
0.
Fraction. Third grade fractions. fractions?
1 over
I like that.
What?
1 over 1.
1 over 10?
1 over 10, right? A 10.
Oh.
Right?
So we got 1 over.
Which also equals, what is this as a decimal? Okay. Who agree with that?
See,
So let's go back to this. S to negative 1.
this is over 2.
1 over S, right? Because this is waves in a second. So it's waves per second. Seconds underneath. So that's why it's S to negative 1. Yes, but you need to recognize on the test, if I put something, 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 S to negative 1, and then say, Samantha, sit up, please, then you'll know that that is a fricative.
Basically, you need to know estimated 1 same thing as 3.
Yes. And it would be nice if you knew why. But I can only ask for so much. Or expect so much, I guess. Okay, so here's our relationship. Frequency equals 1 over period. And alternately, period equals 1 over frequency. That's how they're related. So if you know the frequency, you can figure out the wave's period. If you know period, you can figure out the wave's frequency. So those are your equations. And we'll talk about triangles here later. But if we have a wave, for example, that is 10 hertz, what is its period going to be? 0.10, right? Because it's going to be fraction 1 over 10, a 10. Yes? Okay. What the monkeys? So, here's an example. So what did I say? How many hertz?
10.
How many waves am I going to have?
5.
10 hertz is going to be how many waves?
5 on top of 5 on
20.
What are you talking about? 10 hertz. How many waves per second?
20.
10.
Oh, it's gonna be 10 on top. How many hertz?
All right. First of all, hertz, are we talking about wavelength or frequency?
Frequency.
Frequency. If we have 10 hertz, what is frequency again, by the way? What's the definition?
Ready?
Waves per second. So if I have 10 hertz, how many waves am I going to have? 10. Right?
Yeah.
How many crests am I going to have?
5.
How many troughs am I going to have? 10 of each.
Oh, God.
I made them different colors so you can see each wave. That's one wave, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means that there are going to be how many crests?
10.
10. How many troughs? That equals 20 divided by 2 equals 10 hertz. Okay? Alright, what is the period of this wave? What's the definition for period of a wave?
Time it takes for one vibration.
Time for one vibration. So, this is one vibration right here. How many seconds?
0.1.
0.1?
Yeah. Oh,
Tenth of a second, right? Because remember, this is just, if we know the frequency, then the period is just 1 over frequency, right? So 1 over 10 equals a tenth. Okay? A little bit better? Rabbit. Here is another EM spectrum. Here's another EM spectrum. Each of these have different representations. To where we have, over on the left side here, we have really high energy. What type of wavelengths over here?
Small.
Very small, right? You're real close together. What type of frequency? High frequency, that's right. Right? Because there's a whole bunch of them in a small area. So these are radioactive rays. These are real dangerous. Cause cancers, among other things. Even through UV radiation, right? From the sun. That's why you wear sunblock. You don't get cancer.
What's the gamma rays?
They're radioactive. What are they used for? Basically just laboratory experiments. I mean, that's what they're using. I think they're using them in the Hadron Collider, maybe. Then we get to visible. There's visible light, or harmless. But we have a much longer wavelength, okay? Much lower frequency. And we get microwave and finally radio, okay? Which have really, really long wavelengths, like hundreds of meters long for one wave. A really low frequency.
Don't they use the radiation stuff to like kill cancer? Like chemo,
Flush out.
That's another chemotherapy, yeah. Well, yes, that's another some doses of radiation to try to kill off the cells. But it also does damage to the surrounding tissues. That's why it's so hard on patients. Okay. So next up, you already have your EM spectrum. Okay? You're going to look at yours, and you're going to determine by looking at these values what type of wave this is. This is real simple. You'll like this.
I never really draw.
So write down your 4 problems real quick. Write down your 4 problems. All right. So what you do with this is you're going to look at these values and determine what type of wave it is by looking at your spectrum. Okay? So there's two scales here. At the top we have wavelength, and at the bottom we have frequency. Okay? So you need to determine what your value you're given. Is this a wavelength or a frequency? So number one, is this a wavelength or is it a frequency?
Wavelength.
It's a wavelength. So we're going to be looking along the top here at these values. Where does this fit? Yeah, it's right here. -8, right?
Yeah.
And here's the trick to this. You don't even have to look at the base unit. That's irrelevant. Okay? For our needs. So we have the -8. So our wave type is going to be ultraviolet. So that's the answer. Ultraviolet. Number two, wavelength or frequency? So frequency. Okay, now here's the thing, is if it hits, these on top aren't just for wavelength, and these on bottom aren't just for frequency. It's AM radio. 10 to the 6 hits both. Okay, so you would put AM radio. Question. Okay, number three, wavelength or frequency? Wavelength, so we're on top again. What is it going to be? Infrared. Okay.
Can you explain to me again how you know whether it's on top or bottom?
If it's meters, you're going to be wavelength. Right?
Oh, I get it.
Frequency. Yeah. Then number four, wavelength or frequency?
Wavelength.
I heard wavelength. On the weekends, the wavelength. Where are we? Radio?
Gamma.
We're all the way over here, right? Gamma ray. Any questions on this? You guys comfortable? Easy? Good. These next four shouldn't be a problem. You guys smell the cat seeping through?
What?
Dead cat at home?
She's my body.
Is there not a
Nasty.
It's terrible.
I'm sorry.
There's in those storerooms and vents. They go to the both photography room and Piccolo's room. It's all tied together.
Okay.
Her students named her dead cats.
Of course.
Some of them took the same one.
Ew.
Yeah,
That's very gross.
It's so sad.
All right. So what do we get for number 5?
Gamma ray.
Radio.
It's a frequency,
Radio.
and it's gamma ray. I agree with that.
And negative
6. Frequency or wavelength? Frequency. And what do we get? TV, FM, radio. All of them, right? You have to list all of them. What about 7? Wavelength or frequency? Wavelength. X-ray. And number 8. Frequency or wavelength? Frequency. And that is Yes. Microwave and radio. Both of them.
Hold on, it just got cold.
Because you open the window.
Oh.
Questions on that? All right. All right, this is all your variables and the equations. We haven't talked about the last two. That's okay. We will get to that. You need to put all of this on page 1. You don't need to recreate this chart. You already have the chart on page 1. You still have all that information. Next up, we have a half sheet. Times. You need to put a half sheet of this, the next available page, and underneath that half sheet, You need to write down these directions.
No, they say you guys lost 7-0. Yeah, dude, that's a big party. 7. You don't even get your 7 in indoor there. The boys lost. More than we only have 2 subs. They have like 2 kids. Yeah, you can't read. I can.
Cutting and gluing, writing down direction. With the seconds we have left.
That's a lot of direction.
Make sure you're at least cutting and gluing and put up all the scissors and glue so we can leave. They're not an extra half sheet. There's not another half sheet. Play around.
Do you want to do it now?
Press second. 0. Yeah. I don't want to go play volleyball. Oh, me neither. She's always getting upset. I got a second check. I'm sorry that I can't play volleyball. You can't start either, so she can't.
I know. It was so funny because you're so funny and then she got more than
You could probably guess.
Oh, yeah.
I thought you got
Never forget.
I really do not take her.
Always.
Have a good weekend.
Or like not at all.
Yeah. Bro, it's either way too much or like.
Count. And this round, so you still know you're recording, right? Got all that. Are you,
No.